Stanford University.
Okay, well, welcome to CS 193P, Lecture 12, Fall 2013 and 14. And today we have one topic only, which is core data. And as someone was asking earlier, assignment 5 is due on Wednesday, and then your last assignment, assignment 6, will go out then and be due a week later. On Wednesday, I'm going to be going over the final project requirements, and we're going to continue with core data a little bit, talk about core data with UI table view, and then I'm going to do a big demo. So today's lecture is going to be all slides. I don't usually like to do that just because it's an awful lot of slides all at once, but it makes sense in this case, and I'll be doing the demo for today's stuff on Wednesday. And the next week we'll start talking about advanced segueing, and maybe we'll do some MapKit, multitasking. Not quite sure what I'm going to cover next week because you won't have a homework assignment on that. This core data stuff that we're covering today and Wednesday, that's going to be the topic of your last homework assignment that goes out on Wednesday. So core data, what is core data? Core data is an object-oriented database. Why do we need it? Because in any kind of significant application where we have a lot of data to crunch on, we can't be storing it in NS user defaults or not storing it at all or always fetching it down from Flickr, right? So your current assignment or the Shutterbug demo that we did last week, we're just always fetching our entire model basically every time we want it from Flickr. But what if we had a very large database of photos that have thousands or tens of thousands of little pieces of information about photos? We couldn't be fetching that down every time, and we couldn't store it in its user default. So we need a real database. Plus, a real database allows us to make really smart queries about what our data is. Right now, we can't really query it at all, or almost not at all. We're just kind of displaying it all in tables. So to take the next level of sophistication in our app, we need to do that. So core data is a very, very powerful framework in iOS 7, one of the most powerful in terms of what it can do. I can only just barely scratch the surface in a lecture and a little bit this week. I'm just going to try and get you the basics, and you're going to have to, if you want to do a serious database app in your future, maybe for your final project or beyond, you'll need to do a little bit of extra reading up because core data is massive, okay? But fundamentally, it's a way of creating objects, Objective-C objects that you are going to deal with that are mapped or linked to SQL or XML databases, okay? So it's kind of a bridge between object-oriented land and database land. And database land is dominated by things like SQL, okay? How many people here know what SQL is? Not know how to program in SQL, but know what it is. Yeah, so everyone pretty much. So that's mostly what core data is hooked up is SQL backend. So how does core data work? First, you create a visual map using a tool in Xcode, okay, so dragging and dropping and all that stuff to create a mapping between an object-oriented view of your data and the SQL or tables and rows version of your data. And core data allows really that to be pretty seamless once you've created this mapping, and we'll talk all about that and how it does that. But let's start by looking how we create this visual map in Xcode. Okay, so first, we create the map by doing new file. Anytime we want to add something new to our project, we're going to do new file. But in new file, instead of doing like Cocoa Touch Objective-C class, we're going to go down to where it says core data. See that? And pick data model. Don't accidentally pick mapping model. It's data model that you want here. Okay, the data model is the mapping between the object-oriented world and the database world. So you click that. It's going to ask you what you want to call it and where you want to put it. Some people like to call their model file model if they only have one. Some people like to name it the name of the application. So like last week, if we were doing core data, we might have called it Shutterbug, the name or thing. Sometimes you might have multiple mappings, and it is totally possible. And in a big application, you might well have multiple databases, multiple mappings, and so you would have multiple files. So you want to pick names for your mappings that kind of correspond to what their purpose is inside your application. So, but here we're going to take the default, which is just model. And you can see that it creates this new file. If you look over in the navigator over there, model.xc data model D, okay? And this is our mapping, our visual mapping file. And you can see here that it has some components and we're going to talk about most of them. The components are entities, attributes, relationships, and fetched properties. Okay? So entities are kind of like objects. They're going to map to our objects. In the database world, they're tables. Okay? Attributes are kind of like the columns in a table in a database. In our object-oriented world, they're going to be properties on objects. Okay? Relationships are also properties on objects, but they are pointers to other objects in the database, okay, or pointers to a bunch of other objects. Okay, so these would be kind of like joins between tables in a database sense. Fetch properties are kind of a calculated way to have a pointer to some other properties. I just have to cut something for time, so we're not going to talk about fetch properties. They're really not that complicated. Once you understand how fetching works, much later in this lecture, then you'll kind of get the idea, oh, I can see how maybe fetch properties would work, and then you can read the documentation and figure it out. So that's what the data model consists of: entities, attributes, relationships. That's what we're going to talk about. For our example today, let's say we had a Shutterbug-like application that had photos and photographers. Okay? So your homework is going to be more places and photos. Our demo here, and the demo I do on Wednesday, and the slides are going to be photos and photographers. So those are the two things that are going to be in our database: photos and photographers. So let's create an entity for the photos. So we click Add Entity down there at the bottom. We get this entity. I'm going to change the name from entity to photo. So this is going to be my photo object in the database. And then I can add attributes to my photo object by clicking on that little plus underneath where it says attributes there. And when I add one, it adds one called attribute. I'm going to change the name of that to title. So photos have a title, so I'm going to put a title in there. And you notice as I do this, I get an error, a little red error warning up there. Why is that? That's because the type of my title is undefined. You see where it says type undefined next to title there? So that's not allowed. You have to specify the type of all the properties in your database. And so you just click on that undefined. I'm going to set this one to be a string. The title obviously is a string. Now, what can some of these things be besides strings? Well, they can be numbers, either integers or floating point numbers. Those are all represented in the database as, in your object world rather, as NS numbers. Okay? All your properties, in fact, all the attributes in your objects in the database, all their properties are going to be objects of some sort. So NS string objects if they're strings, NS numbers if they're integers, floats, or doubles, or booleans, NS dates if they're dates, NS datas if they're binary data, that's the second to the bottom. And then transformable is kind of an interesting one. Those will be NS data objects, but you'll provide a little transformable object that will convert them to some other type, like even a C struct or something like that. And we're not going to talk about transformables, but it is possible to store really any data type in the database as long as you provide a transformation object that will convert them back and forth between an NS data. Okay, so here title is a simple one. It's a string. I'm going to add a whole bunch of other attributes here that you can kind of look. It's no more error there right now that I set it as strings, no more error. If I add a whole bunch more, you can see I've added an upload date that I got from Flickr, so that's a date. Even thumbnail data. So let's say I downloaded the thumbnail image data, the image data for a little thumbnail of my photo from Flickr. I can actually put that data in the database as an NS data. Some people ask, how big an NS data could I put in there? For example, could I put an NS data that is the real photo, the big, you know, maybe a megabyte size photo? And the answer is absolutely, you can put them in here. In fact, there's a little switch that you can turn on that says, I'm going to put something big here, store it in another file, okay? But even if you store it in the SQL file, it can usually manage it. It's probably not the best, most efficient way to do it. But yes, you can store big data blobs in core data as well. So there's some example attributes. Let's look at this a different way. If you see down at the bottom there where it says editor style, right? I clicked on that and it switched over to showing the same thing but in a graphical format. So see, here's my photo entity. I can see the attributes. See them there, listed there. And I can still create an entity in this view. So I'm going to create another entity, which is my photographer. I create that entity. I'm going to change the name to photographer. It changes it, okay? I can also add attributes in this view. So I just go down to this button here, Add Attribute. I'm going to add an attribute here, and I'm going to call it Name. So that's the name of the photographer. You can also edit these attributes here in this view by clicking on them, all right, like clicking on the name, and then going up to this attributes inspector up here. Okay? So this is kind of like the attributes inspector in other environments inside of Xcode. So if I click on that, you can see I get a bunch of attributes of my attributes. So here's the name one, and you can see there's the name of it, and there's the attribute type, which you can see is undefined. That's why we have the error up there. See, attribute type undefined. So I'm going to click on that, pop up right there, and change that undefined to be string. The photographer's name is also a string. Okay, so we got that. I can also create relationships between these objects, photos and photographers. I mean, clearly a photo and a photographer have a relationship, right? A photographer takes photos. A photo is taken by a photographer. So I can create relationships between them by control dragging. That's how we like to do things in Xcode. We control drag. So I'm going to control drag between the photo and the photographer, and it's going to create this new relationship between them. Now, the relationship will have a different name on each side. On the photo side, we're going to call this relationship who took, because this relationship is for the photo, who took it. And on the photographer side, we're going to call it photos, because a photographer can take multiple photos, so we'll call it photos. Okay? So this is the same relationship, but it's going to have a property on each of these two objects, photos and photographers, that's a little different. Now, notice that from a photographer's standpoint, this relationship is not just a one-to-one, because a photographer can take multiple photos. And you can see that in the inspector for photos on photographer, there's a type that says to-one. Okay, that means it's a one-to-one relationship. I can actually change that to too many. And when I do that, you're going to see that I get a double arrowhead on that side of the pointer there that's saying a photographer can have multiple photos. Now, we talked about how title is a string and upload date is a date. What type is who took and photos? What type are those? Because they're just properties as well of these objects, but what's their type? And it turns out that something like photos, which is a too many, is an NS set. Okay? That's just going to be its type. Just like title is an NS string, photos is an NS set. What about who took? Who took turns out to be an NS managed object star. So it's a pointer to an NS managed object. NS managed object is the superclass for all objects in the database. Okay, so a photo is going to be an NS managed object, a photographer is going to be an NS managed object. In our Objective-C code, they're all going to be NS managed objects. So, of course, the who took pointer, which is a pointer to a photographer, is going to be an NS managed object star. And we're going to see how we can subclass NS managed object to add all these properties and all this stuff, and then it would be a photographer star, but that's what who took is. It's kind of exactly what you would expect. It's a pointer to an object, which is that other object. Okay? This little delete rule right there, I'm not going to go into detail about this, but the delete rule specifies what to do to who took. Okay, this is the delete rule for photos. You see I'm inspecting photos there. This is the delete rule that says, if I delete a photographer, what happens to who took? Okay? Because who took was pointing to this photographer, and if I delete that photographer from the database, and the answer here, this delete rule is nullify, which means who took would be set to nil. Okay? But there are other rules, for example, cascade, which means delete, when you delete the photographer, delete every single photo that it points to. All right? Cascade the delete throughout the database. So you really want to know what you're doing here. The safest one is usually nullify, set things to nil. But if your database doesn't make sense, if a pointer points to nil, you might need more complicated delete rules there. But in your homework, you won't need anything more complicated than that. So that's basically how we build this map between objects and the database. Okay? So there's a lot of things you can do once you have this map. We're going to focus on the creating entities, attributes, and relationships, and then setting their attributes, and then querying for them, and things like that. But there's a lot of other things you can do in Core Data. I'll mention some of them at the end, and you can go read up on it if you want to do more sophisticated database-y things. So how do we access all of this stuff in our code once we've created this map? And the answer is we need an NS managed object context. Okay, NS managed object context. This context is kind of the hook we need to go create objects in the database, set attributes of objects in the database, query for objects for the database. We all do these through this context. So How do we get a context? Well, there's really two ways to do it. One is you use this class UI managed object, or managed document rather, which I'm going to talk about. And the second way, which I'm not going to talk about, is that you can alloc init an NS managed object context. The reason I'm not going to talk about it is you got to know a little bit about contexts and how they work and how they do thread safety and things like that I don't really want to get into the details of, and that UI managed document takes care of it all for us. Okay, so that's why I'm going to focus on the UI managed document way. If you want to see how the way of alloc initting an NS managed object context, because there's more than that you need to do, like you got to specify where the file is, the persistent store for it, you got to get this map into the picture, all that stuff you'd have to do manually if you don't use UI managed document. If you go and create a new project and say master detail instead of single view controller, it'll actually have a button that says use core data, and when you create that new one, you'll see a whole bunch of core data code that does all this business in there. Okay, but there's no need for you to go look at that. UI managed document is a much simpler, cleaner way to get yourself a UI or an NS managed object context, which is what we're trying to do. So let's talk about UI managed document and how that works. It inherits from a class called UI document. UI document is a whole bunch of mechanism for managing some storage. Okay, UI managed document puts a core data database in some storage. So you're managing the storage of your core data database. So you can think of UI managed document as just like a thing that contains your core data database for you. And all you ever really do is open or save, open or create a UI managed document, and then grab its managed object context, and then use it to do your database. That's it. Okay? So that's what we're going to talk about, how to open or create a UI managed document and then get its managed object context. Then we'll dive back into, now that we have a context, how do we do core data? So here's how you create a UI managed document. You alloc init it. Its designated initializer is init with file URL. You have to give it the URL where this core data database is going to be stored. Okay? I put these 4 lines of code that are in white, that are before the yellow here. They describe how you would create a document called My Document in the user's Documents directory. Okay, so when we haven't really talked about storing files, right? We haven't accessed the file system at all in anything we've ever done. We do this with this class NS File Manager. I'm not really going to cover that this week. Suffice it to say, the file manager can give you the URL of the documents directory for the user. That's what the second line of code there is. And then you can just append whatever you want the name of your document to be, like My Document or Flickr database or whatever you would want to call it. This is going to be the URL where it's going to put that core data database for you. So now you have the URL. You just say alloc init to create a UI managed document. Okay? So this UI managed document, though, you've only alloc init it. You haven't actually created it on disk. It doesn't exist on disk yet. Okay? So we have some work to do to make this thing exist on disk. And how do we do that? Well, we have to create it if it doesn't exist, and we have to open it if it does exist. In other words, we've used it before. So to find out whether it exists on disk, we have to do this file manager thing. File exists at path. So you have the URL to it. You say NS File Manager default manager. That's like a shared file manager. File exists at path. It returns a Boolean whether the file already exists. If it does exist, in other words, if file exists, then we're going to open it. And the way we're going to open it is with the UI managed document method open with completion handler. If it doesn't exist, then we're going to create that document on disk with save to URL. For save operation, UI document save for creating is the argument we want there because we're creating this file. Completion handler. Okay? What's that completion handler business all about? Okay, why do these open and save and create? It says save to URL, but really it's create at URL. Why do they have this completion handler? Well, it's because these are asynchronous. These two methods, open and create, basically, are asynchronous. They don't happen immediately. When you ask the UI managed document, please open this or please create this for me, it might take it a little bit of time. Okay? Why might it take some time? Well, it's possible it could take some time because the file system takes a certain amount of time, but yeah, there's other things involved that we're not going to talk about, like iCloud, where maybe it needs to go check something with some network cache or something like that, because this document is going to be on iCloud, okay, in other devices. Now, one great thing about UI Managed Document and using that to do your core data database is you're on the fast track to iCloud. Okay? iCloud much easier, more straightforward if you just start with UI Managed Document. But anyway, suffice it to say, these two things, opening a document and creating a document, are asynchronous, which means that completion handler, got a little syntax error there, but that completion handler gets called back on the thread you called these methods on, which has got to be the main thread because this is UI Managed Document. This is a UIKit object. You have to call these methods on the main thread, the main queue. So that completion handler will get called back on the main queue when it's done. Okay, no matter how long it takes, it'll get called later when it's done. And then in that block, you just start doing what you want to do. All right, so let's talk about how this might look to see if the file exists, and if it does, open it, and if it doesn't, create it. It looks something like this. And inside that completion handler, if you successfully opened or successfully created it, you're going to call some method of yours. I've called it document is ready. You can call that method anything you want. That says, okay, the document's ready to go. Now you can go use it. Right? And I'm doing the same thing in either case. It's a little bit of a bummer that there's no method like open or create, and it just does it all at once, that you have to do this file exists business, but you do. So you're going to have this little sequence of code in almost any app that uses a UI Managed Document. Okay, kind of silly because it's all very, very simple, similar if-then there, but that's what it looks like. Okay, so now what does that document is ready method look like? It looks something like this. One thing I might do at the beginning of my document is ready is check the state of the document to see if it's in the normal state. Normal state means this guy's ready to go. Okay, what other states could it be in? Well, it could be in the state closed. Closed means you haven't opened it yet or you haven't created it yet. In either case, it's going to be closed. You cannot use a document when it's in the closed state. Some of these other states, like there was a saving error or editing is temporarily disabled because someone else is editing this document in iCloud and it's updating, for example. You're not going to run into those in this class, but you should know that they're there. So checking that at the beginning to, it's a bit mask there. That's why I'm using that ampersand, right? I'm just checking that bit UI document state normal just to see if the document is ready to go. So that might be the first thing I do is check its state to make sure it's ready to go. If it's not, like if it was closed, then I might go back and try to open it or create it again. If it's got an error, I might wait a while and try this again or something like that. So anyway, let's say I have this document in a normal state. Now what am I going to do? Now I'm going to grab that NS Managed Object context and go start doing some core data stuff. That's it. Okay? So this is how we get started. Now, before we dive into what we're going to do with that NS Managed Object context, a couple more things about UI Managed Document. One is that it is auto-saved. Okay? You do not have to save it. And you can save it using this method you see here, but generally we don't. We let it auto-save. Okay? The way we save it is with the same method we used before, but we say UI document save for overwriting. But generally, we don't call this method. We let it auto-save. Okay, so that's an important thing to understand. Okay. Second thing, closing the document. Well, it kind of auto-closes as well. When does it close? When there are no more strong pointers to it. In other words, when there are no more strong pointers to it, when it's going to leave the heap, it gets closed automatically. So you generally don't call close either, but you can do that as well. And close, just like saving, are asynchronous, and you've got to implement these completion handlers to do whatever you want when they're done closing or done saving. Question?
So I assume that it auto-saves before closing, like it's never going to close it without saving.
Correct, yeah. So the question is, does it auto-save before closing? Absolutely. If you say close, or if you stop having a strong pointer to it, it will save and then close. Okay. One thing I will say about saving, the auto-saving, is when you're in debugging, when you're in development mode and you're debugging, sometimes students will get a little confused because they'll go and they'll do something, update their database, and then they'll stop in the debugger, make a code change, and run again, and the data won't be there. Well, because it didn't have a chance to auto-save. So when you're in development mode, you might want to throw in some explicit saves if you're going to be hitting stop in the debugger all the time. Okay? All right, so let's talk about having multiple instances of UI Managed Document on the same document. Am I allowed to alloc init file URL to create a UI managed document, and then somewhere else in my code, alloc init file URL, the same URL, and have two of them looking at the same document? You might think, oh, that can't work, but actually it does. It works perfectly fine. Okay? Works absolutely no problem. The two have their own managed object contexts that are different, but they're both contexts are looking at the same database, and when they both make changes, it's going to save. There is the possible problem, though, that one set of changes in this instance of the UI managed document, and this one might conflict. They might be one's trying to delete an object that another one is trying to set an attribute of at the same time. So if you do have this, it is possible to get conflicts, but usually if we have multiple instances, it's because we have one writer and many readers. It's pretty rare to have two separate controllers or something, each having a document and they're both making changes. That's pretty rare, okay? Especially both making changes at the same time. There's only so much screen for changes to be being made on. One thing to be careful of here is that if one document changes the database, the other one doesn't automatically see those changes, okay? It's not like, oh, I added an object in one managed document. Oh, I don't see it in the other one. Why don't you see it? Well, you don't see it because they have different contexts, different NS managed object contexts, but you're still modifying the same database. So how could you find out if you wanted to find out if another document was doing it? And the answer is the radio station. Okay? We could use NS notification. And so here's an example of having a controller, when it comes on screen, start listening to the managed object context there of a different document. Not the document it has open, but some other instance of an UI managed document. And it's looking for the radio station NS managed object context did save notification. So whenever that other document autosaves, then it's going to get an NS notification saying, oh, it changed. All right? And I'm going to call this method context changed or whatever. And what would I do when that happens? Well, two things. One, I could just refetch all my objects. Okay, I know the database has changed. I'll just refetch them all. We haven't talked about fetching, but I could refetch and get a fresh set of everything. But actually, this context change did save notification gives you an array inside of its user info. There is a dictionary with 3 arrays that are a list of all the objects that changed. Okay, and you can merge those changes into your context using this NS managed object context method, merge changes from context did save notification. You just give it the notification and it'll automatically merge all those changes into your context, which is pretty cool. This is a very cool method, very underappreciated coolness of this method, okay? So you're watching some other context that's on the same database as yours, but it's a different context. You get a notification, you can merge those changes into yours as if you had made those changes. And it's all going to be fine when both documents save because you're merging in the same changes, and the core data automatically deals with it when the same change is being made by 2 different contexts. Only when conflicting ones happen is it a problem for you. Okay, so this all kind of just magically works. So that's watching another context. Probably not going to be necessary in your homework because you're probably going to take a different strategy, which is to have one managed document, UI managed document, and you use its context everywhere in your app. That's kind of a simpler way to do it, and that's what I recommend for your homework. And we'll see in the demo. I'm going to do that in the demo. All right, so now we have an NS managed object context that we got from our document. What can we do with it? Well, we can insert and delete objects, we can change attributes, and we can query for objects. So let's talk about doing all those things. Let's start with inserting. So let's say I want to put a new photo or put a new photographer into the database. I do that with this method right here. It's a class method on NS entity description called insert new object for entity for name in managed object context. So you can see I can't insert an object without having a context. The context is the hook that lets you insert things in the database or query or anything. So you have to have the context. And that first argument, @photo, that is the name of the entity. So remember in the mapping thing when I made a photo entity and I made a photographer entity, this is a string which is the name. So here I am making a photo. And what does it return? It returns NS managed object star photo. And I told you that all the objects in the database are NS managed objects or subclasses thereof. And in fact, that's exactly what happens. So this is just going to make one for you and return it. It's going to be blank or empty. Now, that could mean that all of its attributes are nil, but we didn't see this in Xcode, but when you inspect a property in Xcode, you can actually specify a default value, and it'll have that value. So maybe you want it to have the upload date by default be the date the object was created or something like that. You can go in and create or the date, some fixed date, or you want the title to always be at least the empty string or something like that. You can set defaults. They have to be constants basically in Xcode to do that. And then this object will come back with those defaults set in those fields and otherwise nil. Okay? But if you don't do any of that default setting, all the properties in this photo will be nil. So the title will be nil, subtitle will be nil, the who took will be nil, they'll all be nil. Okay? So great, now I have an object. How do I set those attributes? I want to set the title, I want to set the subtitle, I even want to set who took. How do I do that? You do that using the key value coding protocol. And you've already used this protocol actually. It is value for key, set value for key path, and set value for key path. Okay? So this protocol, which is implemented by NS Dictionary, for example, that's how we used value for key path in those NS dictionaries to do the things like description.underbar_contents. Remember that from Flickr? This is how NS Manage Object works. It implements all these, and you can say value for key @ title, and you can get the title of a photo. Or you can say set value, whatever you want, for key @ title, and set the value of the title. Simple as that. Okay? Value for key, set value for key. Any questions about that? Okay? So the key is obviously just a string, the name of the property in your visual map that we built earlier. The value would be just an object, like an NS string if it was the title, an NS date if it was the upload date, an NS data if it was the thumbnail data or whatever. You can also set, using set value for key, the relationships. So if you had a photographer, which maybe you inserted with that entity description thing, so now you have a photographer as well, you can just say the photo set value, quote, who took, set the value of the photographer for the key, quote, who took, right? Now, what's really interesting is that if you set that value who took, the photos set in the photographer will automatically be updated. You do not have to set both sides of a relationship. And vice versa. If I have a photographer and I add a photo to its photos set, it'll automatically set who took. Okay? And that's because this database has to maintain self-internal consistency, and so Core Data does that all for you, which is really cool. Okay? So you can set either side, and it'll automatically set the other side. As I said before, the too many ones are NS sets, and the non-too many ones are just NS Manage Object stars. Okay? Now, all these changes that you're making, inserting objects, setting all those properties, those only happen in memory. They're not happening on disk until the context is saved. Now, the context has a save method. Okay, if you go look in NS Manage Object Context, it has a save method. But you're not going to call that because you're going to let UI Manage Documents autosave the context. Right? So if you save the document, or you can actually send a message to the context to save itself, either way, it will save out to disk. But until then, all the changes you're making are just in memory. Okay? Now, Core Data has an incredible undo and redo built into it. You make some changes, you say undo, it undoes them. Okay? And you can batch them up, and it can undo things as a group, it can undo just the last change. I don't have time to talk about any of that, but it's really, really cool. Okay? So anytime you have a situation where you're changing a database and the user wants to be able to maybe undo, Core Data is awesome for that. Just like you get NS Managed Object did save notifications, you can also get UI Managed Document did save notifications. So you can sign up for that radio broadcast and find out when the whole document gets saved. Kind of 6 1, half dozen the other in this case, because if the documents get saved, then definitely the context is going to be saved as well. Okay. Calling value for key and set value for key like this, though, kind of results in some ugly code because it's not type checked, right? Value for key and set value for key. That should be set value : for key : that just takes ID, right? Returns ID. So it's really not type checking any of that stuff. And also you end up with a lot of literal strings like @ quote thumbnail URL. And if you ever changed the name of that in your visual map, all your code would just stop working silently and you wouldn't know. So really what we want here is properties. We want to be able to set the title and subtitle and thumbnail URL and all that stuff in my photo using properties and dot notation. So all we need to do that is create subclasses for photo and a subclass for photographer. Subclasses of NS managed object, right? And these subclasses will implement all these properties. And of course, because Xcode is so nice, it's going to do that for you. So let's talk about now how in Xcode we can make it generate subclasses for photo and photographer. So I'm going back to my visual map. I'm going to select photo and photographer. And then I'm going to, from the editor menu, I'm going to pick this all-important menu item called Create NS Managed Object Subclass. Okay? Because that's exactly what it's going to do. And when I do that, it's going to say, okay, which of your models, okay, we only have one, model.xe data model D, but you could have multiple. Which of your models do you want to generate managed object subclasses for? So we'll just pick model. And then it says, okay, well, which of the classes, which of the entities do you want to create subclass for? We'll pick them both photo and photographer here. And it's going to say, where do you want to store them? We'll store them where we store everything else. And then bingo, photo.m&h and photographer.m&h. You see those there got created for us? So those are subclasses of NS managed object. And when you insert an object in the database, or get one back on a fetch, which we haven't talked about, but if you insert an object in the database, when it comes back, instead of being an NS managed object star, it's going to be a photo star or a photographer star. Okay, it's just going to automatically work. That insert entity for entity for name method, which I can never remember the name of, that will return, if there's a subclass to be had, the subclass. All right, so let's look at the code of this. Let's look at photo.h, for example. So you can see that photo.h has made an @sign property for all of my database properties for photo. See, title, photo URL, they're the right type, NS date, NS data. Even who took is the right class. You see, who took is a photographer star. Now, sometimes you'll do this and who took will still be an NS managed object star. Why does that happen? That's because this is a one-pass generation, and if it happens to generate photo before it generated photographer, it won't know about photographer, won't be able to do this. If that happens, just go back to your map and generate them again. And this time they'll both exist beforehand, and so it'll make the right thing, okay? So you can regenerate as many times as you want. In fact, we're going to be regenerating as we change our schema, add more entities, add more properties. We're going to be redoing that regenerate all the time. Question?
It's not importing photographer.h, it's using that @class directive. Is that just saying, I'm telling you this exists, but I'm not going to tell you where?
So the question is, tell me about that @ class photographer towards the top there. Why is that not # import photographer.h? Well, in Objective-C, if all you want to be able to do is declare that something is of a certain type, and you don't need all the methods, you're not going to call any of the methods or anything like that, then you can just do this @ class directive. You can do the same thing for protocols. You can say @ protocol, whatever, and just declare that protocol exists. I'm not going to call any of the methods in it or implement any of the methods. And so it's kind of a forward declaration because eventually anyone who's going to use this is going to start calling photographer methods and they're going to import it. But this is just a way to suppress that compiler warning so that it doesn't say unknown class photographer without having to import photographer.h. That kind of keeps them independent. That way you wouldn't have to generate photographer.h if you didn't want to. If you just wanted photo, then that could be in it. Although, that wouldn't be true because then it would be NS managed object. But anyway, if you have NS managed object there, then just generate them again. All right, so let's look at photographer.h. You can see it has name and photos, right? As promised, photos is an NS set. You see that? It also gave me a whole bunch of methods here for adding photos to the photos set. Because that NS set, that's an NS immutable set. So if I wanted to set the list of photos, I'd have to create a mutable set, put all the photo objects I wanted in there, and then set the whole thing. You know, say, my photographer.photos equals a whole set. With add photos object or remove photos object, I can just add one photo at a time. Right, so it's just kind of, those are convenience methods for adding photos to that photo set. So let's look at the .m's of these though, okay? And what do you imagine these .m's look like? Like setters and getters or @ synthesizes or something like that? And the answer is none of that. Okay, the implementations of these just say @dynamic for all of the properties. Now, what the heck does @dynamic mean? We've never seen that before. @dynamic basically means, hey, I know what I'm doing, don't generate a warning for this, okay? And what does NSManageObject do in this case? Since there's no @synthesize, there's no setters and getters here, the implementation just suppresses the warning basically. And the answer is Objective-C, the runtime, has a trapping mechanism where if you send a message to an object and it doesn't understand that method, right, it doesn't implement that, it can trap and go try and figure out something else to do, okay, without crashing or saying does not respond to selector. And NSManageObject, when it gets sent a message it doesn't understand, it tries to do value for key or set value for key on it, all right? And if that doesn't work, then it says does not recognize selector. But if it does work, then it just works, okay? So that's what's going on here. NSManageObject traps when setters and getters or any method is sent to it, and it tries to do value for key and set value for key. And if it can, all is good, and if it can't, then it says does not understand selector. Anyone understand that? So this @dynamic just says don't generate a warning that I don't implement the setter and getter because I know what I'm doing. Okay? All right. So now that I have these subclasses, how do I use them to access my attributes using dot notation? And so now when I say in this entity description, insert new object for entity for name in managed object context, instead of saying NSManageObject star photo equals that, I say photo star photo equals that. Insert new object for entity for name, by the way, returns an ID, so the compiler is not going to warn you or give an error in either case. But if you say photo star photo equals that, then you can just say photo.title equals whatever you want the title to be. Like if I'm downloading this from Flickr, I might say Flickr data object for key Flickr photo title. Get it out of that dictionary that came from Flickr, and I'm just setting that title in my database. Okay, exactly 100% what you would think it would be. Here's a whole bunch of other examples of what you would do. You can also obviously call the getter, so I could say NSString star my thumbnail equals photo.thumbnail URL. Okay, get that thumbnail URL out of there. Notice that you can't put URLs in the database. You have to put strings and convert them to URLs. I could say photo.lastViewDate equals NSDateDate. Okay, the date method in NSDate gets the current date and time. I could set that as the photo's last viewed date. I can obviously do photo.whotook equals some photographer object, but I can even say photo.whotook.name equals the name of the photographer. So if I have a photo star, I can actually set the name of the photographer who took that photo. Okay, so I'm just using dot notation. This is a normal dot notation. It's just that photographer implements name, and photo implements who took, and who took is a photographer, therefore photo.whotook.name. Question?
Would this require that you set who took previously, or does it like auto-create a photographer?
Right, so the question is, would it auto-create, if photo.whotook was nil, would it automatically create a photographer in the database so that it can say .name equals whatever? And the answer is no. This is normal properties. If photo.whotook is nil, then the set name will just be sent to nil. It will do nothing. So the only way to get things in the database is insert for entity for name, the thing we saw above there, insert new object for entity for name, okay? It doesn't auto-create them ever. Okay, so that's how I access my attributes. What if I, though, wanted to add code to my photo or my photographer classes? I could put that code in photo.m and h, but that would be a problem. And why is that? Well, that might be a problem because, first of all, why would I want to do that? Let's say I wanted to add a class method to photo that took a Flickr database or Flickr dictionary as an argument and created a photo in the database. That would be an awfully convenient utility method to have in photo, right? I could say open square bracket photo, make a photo with this Flickr data in a context, and it could do it, right? So that would be cool. Or if I want to derive a property, like I've got this nice property thumbnail URL, but unfortunately it's a string. What if I wanted to have a UI image, which was the thumbnail UI image? Then I could have a little method in photo that just self.thumbnail URL, turn it into URL, go look it up somewhere, preferably not on the internet, but maybe it would just be a method that would block. I don't know. So that would be cool to add to photo as well. So in other words, it would be nice if we could put all our photo-related stuff in photo.mnh, not just the setters and getters for all our properties. Why is this a problem, though? The problem is, as you change your visual map, you're constantly calling that regenerate method, menu item, the create NSManage.subject, so it's always rewriting them. Okay, it's always blasting what's in there, so we can't do it. Okay, if we edit photo MNH, then we can no longer go into Xcode and say, create managed object subclasses for me anymore. And that's a bummer, because especially in development, we're iterating. We add in some properties, we're adding some entities, changing some relationships. We want to constantly be going back and regenerating those things. Okay? Question? No?
Back to talking about, like, if you could have Xcode auto-set the photographer for a photo, is there a way to, say, set all the defaults for the photographer and then set the default for that relationship in the photo in Xcode to, like, photographer alloc init?
Yeah, so the question is, could I set the default for the whoTook property to be photographer alloc init, basically? So that the default would always default to creating a photographer, and unfortunately you can't do that. But that'd be cool. The defaults all have to be kind of, like I said, static, kind of constants. All right, so what are we going to do then? Because we want to add methods to photo.mnh and we want to add methods to photographer.mnh, but we don't want to have to touch those files. Well, we're going to use a new Objective-C language feature, the last one I'm going to teach you, okay? I think you know them all after this, called categories. Okay? Categories let you add a method to a class without subclassing. Okay? And you don't even have to have the source for that class that you're adding the method to. Okay? So what are some examples of this? Well, in the UI kit, there's a method NSAttributedString draw at point. Okay, well, NSAttributedString is in Foundation. It's not a UI kit thing. It's just a generic attributes on a string thing. But UI kit adds all these, draw at point, and it defines all these other attributes can be on there. And it does all that in UI kit. And it doesn't even need the source for NSAttributedString. Okay? It just needs to know that class exists. Same thing, NSIndexPath. I told you NSIndexPath only had two methods on it, row and section. But actually, NSIndexPath has a whole bunch of methods on it. It's in Foundation. It's just a generic index pointer into an arbitrary, linked list of items. It's just that UI table view wants to call it row and section. So it adds the properties row and section to NSIndexPath. Even though, again, table view is in UI kit, NSIndexPath is in Foundation, not even the same framework. Okay? So how does this work? And it looks like this. You have an interface and an implementation, just like a class, but you say, instead of saying @interface, name of class, superclass, you say @interface, the name of the class I want to add methods to, and then in parentheses, what I'm going to call this category. And you can call it anything you want. So here I've called it add-on, but you could call it Flickr, you could call it create, whatever you want to do. Then you just list all the methods you want to add to this class, and they can be properties. Here I have a read-only property and another method. You just put them on there, and then @end. Okay? So that's all you need to do. Now anyone who wants to call these methods just has to import this header file that has this in there. Now, there's a big restriction on categories, gigantic restriction. You can't use any instance variables. Okay? So the implementation of your methods cannot use instance variables or any stored state at all. Okay? There are ways kind of around it, but they're hacks. Okay? So generally, categories is for methods. They have no state. Well, what good is that? Well, the object that you're adding the methods to, it has a lot of state. And so these methods would all be implemented by using the state of the object you're adding the methods to. Okay? So let's look at an example for these two methods. So here's the implementation, the @ implementation of Photo's add-on category. So I'm adding these two methods to the photo class, which is that thing we generated in Xcode. Image, you see, it just uses self.photoURL. Self is the photo because these methods are being added to photo class. Okay, so self is a photo. .photoURL gets that attribute, gets that data. That's probably, it actually probably would be self, it would be NSURL from string, self.photoURL string, because we can't put URLs directly in the database. But anyway, and then it would say return UI image with data, and return the image. Okay? So no instance variables there. It's not using instance variables. Same thing with isOld. Might say self.uploadDate, time interval since now is greater than a day ago. Okay, question?
So by no instance variable, you just mean like you can't like access it through like the underbar, the underscore, that?
No, I mean you cannot declare any new ones.
Oh,
Okay, so you cannot use any instance variables here. You could only use instance variables in the class you're adding it to if they make them public via properties or whatever.
I couldn't quite hear you. Did you say that the instance variables you access have to be public, or they can be private? Or?
Okay, you can't have any instance variables in a category, period. Okay, you cannot declare any. If you want to use instance variables of the class you're adding the methods to, right, then they have to be public because all you can do is see the public header file. You don't see the implementation of photo. You're adding these methods to it blind. You don't know anything about its implementation. So anyway, so this is called categories. I don't teach this to you early on because this is easily abused. All right, you could add methods to UIKit classes. There's no reason you couldn't. You could add methods to, foundation classes, completely unrestricted. The only thing is when you start doing that, your code can kind of get a little obfuscated. People are like, what? I didn't know that, this UIKit class had that method, and it's because you've added it as a category over here. And so it's just kind of hard to understand. But sometimes like this, we want to do that because it kind of, it collects our code and it makes things look nicer. Question?
Overwrite with that.
Okay, so the question is, can I override or overwrite, really, a method that already exists? And the answer is, don't do that. Okay, that is really hard to understand for people reading your code what you mean by that. So only add methods, don't try to replace or otherwise, use the same method. That's a good question. All right. So here's a common category method we add for subclasses of NSManageObject, which is creation. So imagine I had this category called photo create. And I'm going to have this method that I'm going to add to photo called photo with Flickr data in managed object context. And it's going to query the database, see if that photo already exists. It's going to return it if it does. If not, it's going to insert new object for entity for name, initialize the photo from the dictionary you sent, et cetera, et cetera, et cetera. It's going to do all that work all in one method. So that if someone wants to create a new photo using Flickr data, they can just call this one method, class method in photo. Okay, so this is a classic reason why we would do this. Okay? So how do we create a category? So we go to Objective-C, new file, of course, and instead of saying Objective-C class, right, you see Objective-C class there, you say Objective-C category. And instead of asking you the class and the superclass, it's going to say what class do you want to add a method to, and what do you want to call this category. So I'm going to add methods to photo. I'm going to call the category Flickr. And then it creates photo plus flickr.h and photo plus flickr.m. Now, this is kind of the standard naming convention for a category. You call it name of the class you're adding the methods to plus the name of the category. Okay, the plus as a separator, and also because plus means you're adding these methods to it. So it's kind of a naming convention. You could call those header file and the implementation file anything you want, really, but this is what we 100% of the time call it. Okay, name of class plus category. And you can see that it's created a .h for me and a .m. And I just put the methods I want to add in the .h, and then I implement them in the .m. It's just that I can't, unfortunately, have any instance variables. Okay? Yeah, question?
So if I just created like an empty text file and then drag it in, how will Xcode know whether it's a category or is it a order?
Yeah, so the question is, instead of using new file category, if I just created an empty file and started typing this stuff in, how does Objective-C know this is a category? Well, when you go new file category, that's just a convenience. It's just creating this for you as a convenience. You could certainly just type this stuff in. It knows it's a category because it's @interface photo parentheses Flickr, right? It knows that that parentheses thing, if you have a in parentheses with some word in there, it knows that means a category. And then same thing on the implementation side. You say, okay, I'm providing the implementation of that category. So the answer is, yeah, you could do that. New file is just making it easy for you, so it does this. That's all. Okay, any questions about this? And we'll see this in the demo on Wednesday, where we'll add a category to photo. Okay, so now you know how to insert objects, you know how to change their properties, we know how to create the custom subclass, so we can do all this with dot notation. What about deleting objects from the database? Okay, this is all too easy. Okay, as Darth Vader would say, it's all too easy. You just call delete object on the context. Give the object, bam, it deletes it. Now, Deleting the object can have ramifications, right? You delete a photographer, it's going to set that who took to nil, okay? Assuming you don't do that cascade delete rule, in which case it would delete the photographer. But, okay, so deleting, you know, has ramification. You got to know what you're doing deleting. It's very easy to do. Two things to think about this. One, remember it doesn't actually delete the photo or delete the object until you save. So the autosave comes around and it'll be deleted. That's just a minor point. It's kind of obvious. Same thing with all of the changes you make. They don't happen on the database until that autosave happens or until you explicitly save. But the second thing with deletion that you got to be really careful is, see that argument photo, delete object colon photo? If that photo is a strongly held to pointer, you better set it to nil right after this, okay? Because you cannot access that photo anymore. It is invalid, right? After you hit delete photo, or delete object rather, that thing you deleted, get rid of all your strong pointers to it because it's no good, right? It's been deleted. So if you try to say photo.title equals something on the next line, I don't even know what would happen, something bad. Don't do it. Okay, I mean, that's completely obvious, right? But it's something people forget and then they're like, wow, it's not working, okay? One other thing about deletion that's kind of cool, Core Data will send the method, send a message, prepare for deletion, to all objects when you send delete object. Okay? So if I say delete object photo, that photo will be sent, if it implements it, prepare for deletion. And the cool thing is you can put this prepare for deletion in a category. So you can add the prepared for deletion method to photo or photographer in a category. Now, what would you do in that prepare for deletion? Well, you don't need to do anything with the who took or the photos or anything like that. That's all taken care of for you. But what if you had another property somewhere in the database which was counting the photos or something like that, and deleting this photo would change that count? And why would you have such a thing? Because it's possible to just query the count of photos that a photographer has, for example. Maybe, you know, it's a count that for efficiency, you're checking something about the photo and keeping this count. And maybe if you delete the photo, you need to update that count. Well, you can do that, all that kind of stuff here in prepare for deletion. Okay? You can basically do anything in the database you want in prepare for deletion. And the thing that's being deleted is not yet deleted. Okay? So it's still in the database at the point this is called. But after you return from this method, then the object's going to be deleted. So you better have updated the database however you need. Okay? Got that? All right. So now you can create objects with insert. You can get and set the properties. You can delete the objects. One last thing to want to do in a database, query. Okay? Which means go out into the database and get me objects that match some criteria. Okay? So we do this in Core Data with an object called an NSFetch request. Right? It's exactly what you think it is. You're requesting to fetch some objects from the database. You need 4 things to make an NSFetch request. The entity to fetch, and this is an interesting one because when you fetch from the database, you can only fetch, fetch when you execute it, returns an array of objects, an array of NS-managed objects or subclasses thereof, as you might imagine. That array all have to be the same type of entity. Okay? So there's no way to do a fetch in a database that gives you an array back. Some of the things are photos and some are photographers. They all have to be photos, all have to be photographers. So you have to specify the entity that you're trying to fetch. Okay? Understand what I mean by that? That's the most important thing. In fact, the way you create the fetch request is by specifying what kind of entity you're trying to fetch. Then you can specify optionally how many of those objects you're willing to accept and how big a batch. If you're fetching a whole bunch of them, you can specify how many to get at a time. Because it's not going to, if you say, give me these photos and it matches 10,000, it's not going to load 10,000 things out of the database and into memory. Okay? It's going to kind of give you 10,000 placeholders, and then it's going to fetch them in little batches. And you can specify the batch size depending on how you're going to use the object. If you use the information, if you're displaying in a table view, well, you can set the batch size real small, like 10 or 20, however many, scrolling around in a table view, you can only see, 10 or 20 at a time. So you can have a small batch size. Okay, so you control that. Sort descriptors, which we're going to talk about, which is how to sort the results, because the results are an array, not a set. So the array means it's ordered. So you got to specify what order to give those objects back in. And then most importantly, the predicate. And the predicate says which of those entities you want. Which photos? Which photographers? Okay, so let's look at these 4 things. Here's what a fetch request looks like. You create it with fetch request with entity name. That tells you what you're fetching out of there. And then you can set things like the batch size and the fetch limit. They're just properties on the request. And then the sort descriptors is an array of sort descriptors. We'll talk about why that's an array. And then the predicate is NS predicate. So this is how you would set up a fetch request. Okay, very simple. So you can look up in NS fetch requests how batch size works, how fetch limit works. I'm not going to get into the detail about that for time reasons, but I am going to focus on sort descriptors and predicate because those are really important. So let's look at the sort descriptor. You create a sort descriptor using this class NS sort descriptor. And it has quite a number of class methods to create it, so you should go look at the documentation, familiarize yourself. But they're generally of the form sort descriptor with key. So that's the key you want to sort by. So if I were fetching for photos, I might want to get the result sorted by the title of the photo. That would be a classic thing. Ascending is whether it's alphabetical order or reverse alphabetical order. And then the selector is interesting there. That is the method that will be used to compare photos while it's sorting them. Okay? So it's going to sort the results by the title, and it's going to be using the method here, localized standard compare, to compare the titles to know how to sort them. Okay? Now, what is localized standard compare? Localized standard compare means sort them like they would look in the Mac Finder, basically. Or that's kind of a colloquial way of saying it, but basically sort them how real people think things should be sorted. Not case insensitively, do the right thing with diacritic marks if it's a language that has a lot of diacritics, that kind of thing. Okay, that's what localized standard compare is. There are other selectors that are sensible if it was a string type property, like localized case insensitive compare, which sounds the same, case insensitive sorting, but the diacritics are handled differently in that case. So that's why you'd want to use standard compare. So you can look up in sort descriptor, see what kind of methods are kind of built in. You can sort by things besides strings. You could say sort descriptor with key upload date, and then the selector would want to be compare colon. Compare colon is a method most things, if not all, except for NS data maybe, things in the database will respond to. Compare colon, it's kind of the default compare, but it's not going to do what you want usually for strings, so you want a better one. But it will work for dates and things like that, numbers, things like that. So that's the selector. You can leave that selector off when you create the sort descriptor. Just say the sort descriptor with key ascending, close square bracket, and you'll get compare. Okay, so compare is kind of the default one you get. Why do we give an array of these things to the fetch request? Okay, when we saw request.sort descriptors, it was an array of these. Well, that's the old last name, first name thing. If I said, hey, I'm going to fetch some people, some employees out of an employee database, and I want you to sort it by last name. Well, of course, all the Smiths would all sort to the same thing. So you want to then sort those by the first name. So you provide 2 sort descriptors, one that sorts by last name, that's the primary sorting, and then one by first name is the secondary sorting. Another common one is a table view. Pay attention because your homework, you might have to do this, is maybe I'm doing the table view like you're doing in your current assignment, and I'm sorting, basically by the name of the place in the place one, but I'm supposed to do it by country, sections by country. So really I need to sort first by country. Then I sort by the name of the place in the country. Okay? So that's an example where you might use 2 sort descriptors. Country sort, then the place. That's so that I can get them in order so that they're by country first. Okay? Make sense? All right, predicate. So this is the guts. This is the thing that says, which photos do I want? Which photographers do I want? And the NS predicate looks a lot like NS string when it comes to creating them. So just like we have NS string with format, we actually have NS predicate with format. Okay? And you can specify this arbitrary string. Now, this is good and bad. The good news is this is incredibly flexible, and you can specify unbelievable kinds of criteria for finding what things you want in the database. The bad thing is it's a little bit for you to learn, because it's almost like you have to learn a little bit of a language here, the predicate language for how you specify what you want to choose. The basic format allows you to do the %@ replacement just like you could with NSString. So here, for example, I'm looking for all the thumbnail URLs that come off of Flickr 5 server. So I'm saying predicate is thumbnail URL contains Flickr 5. But I don't put the Flickr 5 right in there. I use %@ and it's an argument. So I can use %@ replacement. And I can replace not only the right side, what's contained, but I could replace the left side, like which property I want to search to see if it contains Flickr 5. Okay? And we'll talk about contains in a second, but question?
So this doesn't just convert it into a string and feed it into something, right? Like it would recognize, the function itself recognizes this is an argument, this is an argument.
Correct.
Okay.
Yeah, so this is not just, the question is that just making a string and passing it off? And the answer is no. NSPredicate is actually looking at what you're parsing. And now it can't know what database you're doing a fetch into, so it won't be until fetch time that it might fail. If you say thumbnail foo contains whatever, predicate's going to let you create that predicate, but then when you go to do the fetch, it's going to say no property thumbnail foo in this database. Okay, so you see this one's contains. Contains means, you know, that string is contained in the other string, exactly what you want. So the contains is one of the words in this little language for setting up predicates. Here's a whole bunch of other examples. I'm not going to teach you all of predicate today. You're going to have to look at NSPredicate documentation to see what it can do. But here's a bunch of examples. Obviously, you have equals. So you can say unique ID equals %@, maybe the Flickr object, the Flickr photos unique ID. You can say name contains with square bracket C. That means contains case insensitively. Okay, so that's part of the thing. You can have greater than and less than. So if I had a date property called viewed, I could say if viewed is greater than a certain date, like today's date, for example, or it would be, I guess, less than today's date, or less than today's date minus 24 hours, or whatever. So you can use greater than and less than. You can use dot notation to follow relationships. So you can say who took dot name equals CS193P instructor, right? So you could have, this would be a query or a predicate for searching in the photos entities. So you're trying to get photos entities, but you want photos entities where the who took name is some photographer's name. So the things you're getting are photos, but the query, the predicate you're using to find them, is looking over at the photographer using dot notation. You understand this? Okay, you definitely need to understand this for your homework. And you can do really powerful searches like, give me any photo whose title contains, give me, this would be a photographer query. So let's say I'm searching photographers. Give me any photographer where any of its photos title contains this. Okay, so that any is kind of a special thing. That means I'm a photographer. Look at in the database at all the photographers. Look through their photos set to look at all their photos. Look at all the titles of all those photos. See if it contains this string, and if it does, return that photographer. Okay. Now this seems, I'm sure you're like, whoa, that is going to take a lot of computing power if I have thousands of photos and hundreds of photographers, but actually databases know how to do this really, really well. Okay, and all this stuff that you're doing is generating stuff that happens on the SQL side. So you're going to get a big SQL statement generated here to join these tables, do these searches. It's going to be incredibly efficient. And one thing to understand about Core Data is it's very efficient. Okay, the SQL it generates is totally tuned to the max. Okay, having said that, there are certain queries that are more efficient than others that can accomplish the same goals. So if you get to be a Core Data expert and you start building big databases and you're making a lot of big queries on big data sets, you will eventually learn what makes a good query, what makes a not so good query, etc. For your homework, you don't have to worry about that yet. Okay, let's get the basics first. Question?
I'm assuming with the templating, you can't pass any of these operators in as a %@ when you're building a predicate?
So the question, you mean like the greater than and the less than, can I pass that in as a %?
Like I'm assuming this is to prevent something like SQL injection.
Yes, you can't do SQL. The question is, can I do SQL injection by using the %@ to basically make the operator be, you know, configurable? And the answer is you can't do that. NSPredicate would complain about that. NSPredicate does know when a %@ is a right hand or a left hand of one of these expressions. So the answer is no, can't do that. Okay, so there's a bunch of examples. Again, I'm just trying to give you examples. We're not We're not trying to teach you predicate here. There's also a compound predicate. In the NS predicate, you can say and or. So you could say name equals %@ or title equals %, okay, if you had an object that had a name and a title. Or you could say who took dot name equals blah or title equals blah. Kind of wouldn't make much sense, but you could. You can also create compound predicates in code by using an and predicate or an or predicate in NS compound predicate. And it just takes an array of other predicates and makes a compound one. Okay? That's like if you want the anding and oring to kind of be if-then, okay, in code as opposed to just built into the string. Advanced querying, for time reasons, I'm going to skip this, but key value coding, which is the thing that lets you use dot notation to search down inside of a dictionary, right? It's the value for key path business. You can kind of do value for key path in the database. And there is, we didn't talk about this, but there is a really cool thing in key value coding, which is functions. And one of the functions, which you probably will need for your homework, so pay attention, is @count. So if you put @count in the thing you're querying for, as long as the thing to the left of it is an array, or a set, one of these NS sets, then it will replace that with the count of how many things are in that set. So for example, if I wanted to find out all the photographers, give me back all the photographers who have taken more than 5 photos, my predicate would be photos.@count is greater than 5. Okay? And there are other @signs, @average, you can look through to find out what there is. I put a link in here. You know, I don't usually put links in my slides, but this one is worth looking at. And this also works, it works for any key value coding thing, so like for dictionaries. So go back to the Shutterbug and try doing property list results, value for key path, photos.photo.average.latitude. Anyone hazard what that returns? Yeah?
Like the average latitude of all the photos.
Correct. It returns the average latitude of all the photos. Okay? So that's something for you to have fun with. You can build even more complicated expressions, and there's a mechanism to query into the database and not get back an array of NS-managed objects, but to actually get, you know, kind of data that's been calculated from what's in there. And when you do that, instead of getting an array of NS-managed objects, you get an array of NS dictionaries. And those dictionaries contain keys and values, which is the data you look for. This is all super advanced. See the title of this thing, Advanced Querying. I'm not going to talk about it in this class, but just so you know that fetch request can be used to create something that's actually fetching data rather than just fetching managed objects. Okay? All right, so let's put it all together for the request. So I've created, so this is a request, okay, that's going to get all the photographers. So I say fetch request with name photographer, who have taken a photo in the last 24 hours. So I get yesterday, which is NSDate, date with time interval since now, minus 24 hours. Predicate, any photos.upload date greater than whatever, okay, yesterday. And then I'm going to sort it by the photographer's name. So an array of one sort descriptor where the source descriptor is the name. It's going to be using compare here, which is probably not good. I probably want to say selector @localized compare. Okay? So that's how I would create a request. Now that I have a request, how do I execute it? And the answer is we use the method execute fetch request in NS managed object context. So I told you NS managed object context is the hub of everything, and it's the hub of querying as well. And you can say it has a little extra argument there, error : @error, which will return an NS error and tell you what went wrong if things went wrong. And you can tell things went wrong with the fetch request if execute fetch request returns nil. Okay, if execute fetch request returns nil, something went wrong, and that @error will be filled out with some error. If it returns an empty array, that's not nil, empty array, that means nothing matches what you're requesting. So no error, it's just that you requested objects and there aren't any that match that predicate. Okay? Otherwise, it's going to return an array of NS managed objects. Okay? Or subclasses thereof, photos, stars, photographer stars, whatever you set as the entity name, it's going to pass an array of them. Okay? That's it. It could not be simpler to query. One thing about the query results, by the way, if you query 10,000 things, you're not going to get 10,000 things. you're going to get 10,000 placeholders. And as you start looking at the attributes, then it'll start faulting them in from the database. Okay? So there's a lot of performance optimization going on behind the scenes that you don't really need to know about, but faulting is happening. For those of you who are database heads and you're probably worried about this, no worries. It's not actually pulling all that data out of those tables. It faults them in as you access them. Quick thing about core data thread safety. NS Managed Object Context is not thread safe. In other words, you can't just use it in multiple threads, but you can safely access them. Most managed objects, we create them with this kind of thread containment, thread concurrency mechanism. There's a method in NS Managed Object Context which you will want to use called perform block. It just takes a block with no arguments. Anything you want to do on a context, inserting objects, querying, anything, do it inside a perform block. Why do you do that? It'll do it on the safe queue for that context, and it'll be guaranteed to be safe, thread safe. Now, that safe queue might be the main queue, so this is not necessarily giving you multi-threaded, okay, but it will be safe. So get in the habit of doing this, because if you do come to a day when you're using NS Managed Object Context and you're creating them on different queues, so you can load the database in one queue while you look at it in another or whatever, which is all doable, you need to be doing this perform block. It doesn't hurt to do it, so might as well do it. And parent context I don't have time to talk about. There is a ton of other stuff actually in core data I don't have time to talk about because we're at the end of the lecture today. Optimistic locking, rolling back unsaved changes to states that make sense. Undo and redo I talked about. Staleness, you do a fetch and it sits around for a long time. The data could be stale, might need to be refetched, thrown out and refetched. It's just a massive amount of stuff. Can't talk about it. When you walk out of here, what you really want to be comfortable with is you know how to create the visual map, insert objects, make the subclasses, use dot notation to access them, delete objects, and query for them. Okay, that's the fundamentals of core data. That's what we talked about today. That's what you should need to know how to do for this class. And then outside of that, you just need to know that there's a lot more. And if you're going to do serious database work, you need to do some reading up on that. Okay, so that's it. Sorry to keep you a couple minutes over, and I will see you on Wednesday with a big demo of all this stuff.
For more, please visit us at stanford.edu.